All right, this is 6.6, example number 3. How do I change, how do I write down this cylinder into vector value function? Okay. Cylinder is if I project that cylinder into xy plane, it looks like a circle here, right? Circle. So we know the equation of a circle. So but this is not exactly circle. This is an ellipse. I don't know you can see this ellipse or not, because if I divide both side by 16, does it look like x squared over 4 plus y squared over 16 equal to 1, right? So in x direction you go. If I draw in xy plane, okay, let me do xy plane. So it's going to be just a 2 there, and then y you're going to do 4. So it's going to look like that. So that ellipse, but if the z is, you can choose anything you want for z. So let's, z is just like just a z. Let's call it in this case maybe, let me see, I should call this one z as if I u or v, right? So I want to change into uv, so let's call it v, and then x. So x is x and y. This is like x and y, so it's a ellipse. So if I choose just a 2 cosine of u, and then y is 4 sine of u, that will take care, right? Because if I square this, if I just, let's check this one, right? Just check. If x is 2 cosine u, that means 4 times 4 cosine square u. I'm just plugging here into here, plus y squared is 16 sine square u. If I, that's going to be 16 cosine square u plus 16 sine square u, and that's just, if I pull out the 16, that's just cosine square u plus sine square u, and that's the 1, right? 16. So that will work out. So this is a one form, right? So that means if I want to write down this in vector form, so that's a vector is uv is going to be, let me erase this part here, is going to look like, let me change the color too. So it's going to look like a v, or no, so this is a 2, let me erase this again, and that's just a 2 cosine u, that's x, 4 sine u, and then v. I mean, you could write down this way too, okay? You can write down 2 cosine v, 4 sine v, and this is u. You could do that too, doesn't matter. So u and v are parameters. So in this case, the v is like you can, I don't know, it doesn't have any particular range. This one goes forever, right? Negative infinity, infinity. And but u is, remember that u is 0 to 2 pi in this case, the first part. If you look at the first one, that's a, and in this case, if you want to use this one, then your v is between 0 and 2 pi. Okay. All right, this second one is a little bit tricky here, but y equal to square root of x. I mean, we are familiar with this one, so make sure you look at this problem. This is going to be in your homework too. So this is your y equal to square root of x, and we're gonna, what are you gonna do here? Surface revolving about x-axis, so it's gonna be like that. Okay, so it's gonna look like that. So it's gonna rotate around like this. So that means okay, so here your x is just gonna be just a u. Okay, I'm gonna use that, and then your y is gonna be square root of u, but remember that it's gonna rotate about x-axis, right? So even if you look at that, this is rotated about x-axis, so it's gonna look like this, and it goes up to 4, and then we're gonna have like this. Okay, so if you look at this like that. Okay, so this is gonna be cosine u, or maybe I should this is a u, means you have to be v, right? V, and then this is z equal to square root of u sine v, and that will give me the rotation. So you can just plug it into your in your calculator or your Desmos. So it's Desmos surface surface or 3D. You can just put a Desmos 3D and you can plug in there. Just plug in there like a put a parenthesis and then you put u square root of u. That's the same thing, cosine v square root of u sine v. If you plug in there, you're gonna see that picture. Okay, this picture. This is z and this is y and this is x. So I might ask you this one in an assignment. All right, so similar like that, but maybe in a different direction. Just check it out. That